Welcome to day 17. We're going to do sine and cosine addition and subtraction identities. Normally I would prove these to you. I'm going to record the proofs of these, but I'm going to do it on separate videos and link them to the page. If you're going on to calculus, going on to study higher math, I would suggest that you look at these proofs, but for the rest of you, that you can do this because we're on this AMI thing. If we were doing this in class, I would definitely prove these to you, but for now, I want to introduce these to you. If we have the sine of two angles added together, alpha plus beta, this is always going to be sine alpha cosine beta plus sine beta cosine alpha. So if we knew, let's say, sine of alpha was 2/3 and cosine alpha was the square root of 5 over 3, and that sine beta is equal to 1/5, and cosine beta is equal to the square root of 24 over 5. I'm not going to go ahead and simplify that right now because it's easier to work with to illustrate this the way it is. And I asked you to find sine alpha plus beta. Then you would say that is sine alpha. Sine alpha is 2/3 times cosine beta, which is the square root of 24 over 5, plus sine beta, which is 1/5, times the cosine of alpha, which is the square root of 5 over 3. So that would give me 2 times the square root of 24 over 15 plus the square root of 5 over 15. That's going to give me 2 square roots of 24 plus the square root of 5 over 15. That's the way I would do this. We could find, let's say we wanted to find the sine of pi over 12. We could say that's the same as sine of 3 pi over 12 plus 2 pi over 12. 3 pi over 12 is pi over 4, and 2 pi over 12 is pi over 6. So we could say by this identity, that's the sine pi over 4 times cosine pi over 6 plus sine pi over 6 times cosine pi over 4. We know the sine of pi over 4 is the square root of 2 over 2. We know the cosine of pi over 6 is the square root of 3 over 2. Sine of pi over 6 is 1/2. And the cosine of pi over 4 is the square root of 2 over 2. So that would give us the square root of 6 over 4 plus the square root of 2 over 4. So the sine of 5 pi over 12 is the square root of 6 plus the square root of 2 over 4. If we look at the sine of alpha minus beta, and again, I'll show you the proofs of these on separate videos if you're interested in looking, but if you are going on to calculus or other advanced math, you probably need to look at those proofs. But for what we're doing, we'll do problems like this. So here, this identity is the sine alpha cosine beta minus sine beta cosine alpha. The only thing that changed from here to here is the positive and the negative. Everything else stays the same. Sine alpha cosine beta, sine alpha cosine beta, sine beta cosine alpha, sine beta cosine alpha. But when this was sine alpha plus beta, there's a plus in the middle. Sine alpha minus beta, there's a minus in the middle. Again, if we wanted to find here, ask you to find sine of pi over 12. We could say that's equal to, let's see, sine of, if we were going to do this, three pi over 12 minus 2 pi over 12. That would give us sine 1 pi over 12. And according to this identity, that would be sine, oops, sorry, it's the same as pi over 4 minus pi over 6. And so according to this identity, that would give us sine pi over 4 cosine pi over 6 minus sine pi over 4, oh sorry, pi over 6 cosine pi over 4. We know sine pi over 4 is square root of 2 over 2. Cosine pi over 6 is square root of 3 over 6, or square root of 3 over 2. Sine pi over 6 is 1/2, and cosine pi over 4 is square root of 2 over 2. So this would give us the square root of 6 over 4 minus the square root of 2 over 4, or the square root of 6 minus the square root of 2 over 4. So using these identities, you can find some exact values of sine and cosine that we couldn't find before. Let's look at the cosine addition and subtraction identities, and again, I'll show you the proofs in other videos. A cosine of two angles added together, alpha plus beta, is going to be cosine alpha cosine beta minus sine alpha sine beta. This time, a cosine of alpha and beta are multiplied together, and then we subtract the sine of alpha and sine beta. This, for the cosine addition identities and subtraction identities, the sign in the middle is going to be the opposite. Everything else is going to be the same, just like it was for the sine, but we're going to do the cosine alpha minus beta identity, and that's going to be cosine alpha cosine beta plus sine alpha sine beta. Again, I'll show you proofs in a little while, but let's look at cosine of 5 pi over 12, since we've already done those. And we'll look at cosine pi over 12. We could say this is the cosine, like we did before, of let's do it a little bit different this time. Let's use a subtraction. Let's say this is the sine of 8 pi over 12 minus 3 pi over 12 to get 5 pi over 12. Showing you this with a different way just so that you can kind of see how we play with these numbers to make them work. I'm doing this because 8 pi over 12 reduces to 2 pi over 3. We divide top and bottom by 4 minus, and this becomes pi over 4. So now I can apply the subtraction identity and say that's equal to cosine 2 pi over 3 cosine pi over 4 plus, because I've got subtraction here, I got plus here, sine 2 pi over 3 sine pi over 4. And that's equal to cosine 2 pi over 3 is negative 1/2. Cosine pi over 4 is square root of 2 over 2. Sine 2 pi over 3 is the square root of 3 over 2. And sine pi over 4 is the square root of 2 over 2. We're getting all these numbers from the unit circle, which you should have memorized by now. That's negative square root of 2 over 4 plus the square root of 6 over 4. That's also the square root of 6 minus the square root of 2 all over 4 when we combine like terms. Or we combine everything over with this common denominator. Cosine pi over 12, we could say that is, let's say that's cosine 3 pi over 12 plus negative 2 pi over 12. Now recall, this is the same, sorry, we'll reduce this first. Cosine pi over 4 plus negative pi over 6. Now I'm using the addition identity just to show you how you can manipulate this and get you used to seeing how you can change fractions around. Recall that cosine pi over 6 is just going, instead of going this way for pi over 6, we're going this way, but it is a reflection across the x-axis. So if this was the point square root of 3 over 2, 1/2, this is the point square root of 3 over 2, negative 1/2. So the cosine of negative pi over 6 is square root of 3 over 2, and the sine of negative pi over 6 is negative 1/2. So we're going to say, since we're using the addition identity, that is this one. So cosine alpha, cosine pi over 4, times cosine negative pi over 6, minus, because we're using the addition identity here, sine pi over 4, times sine negative pi over 6. Cosine pi over 4 is square root of 2 over 2. Cosine negative pi over 6 we just established is the square root of 3 over 2. Minus sine pi over 4 is the square root of 2 over 2. And sine negative pi over 6 we just said is negative 1/2. So this becomes square root of 6 over 4 plus square root of 2 over 4, which is square root of 6 plus the square root of 2 over 4. And that's how we use these addition and subtraction identities. Again, I'll show you the proofs of these and I'll link them to the page, but this is primarily what we're going to be doing. Rewriting the fraction as two things that we can reduce to angles on the unit circle, and then applying the identity.